Okay, so now we're going to go further into the solver function. So I'm just going to open up a quick start. I'm going to go the two-stage gas compressor with intercooling and leave everything as standard. So as you create the quick start, it actually solves it for you. But if you want to solve it with a fixed flow rate, you can select that here at the solver. Otherwise, if you just want to solve it with the calculating the flow rate, you just press the play button. So if you have multiple lines, you can select which line you're viewing here. In this case, we only have one line, so you just select that one. Here you can select pipe geometry, so it'll just view your, show you your pipe geometry at the ambient or process temperature. So, for example, through a process, if you're heating up your pipes or you're cooling down something, it'll expand or contract. So you can just view that there. And then your color line, this is this gradient here. It just visually displays either your flow regime or your fluid temperature or Mach number or pipe integrity for you. So if we want to look at the fluid temperature, for example, you have a scale here, so it varies between blue at 25, which is what your source is at, and red at 331 degrees. So as it goes, it heats up over the first compressor, cools down over the intercooler, stays at the same temperature, and then heats up again over the second compressor. You can also view your fluid pressure, which, as you expect, pressure increases, doesn't change through the heat exchange, and then increases a second time over that, and you can view that here. So you have your vapor fraction, which in this case it's gas velocity. So this liquid velocity is not going to show you anything because there's no liquid. Mach number, you can also go, so gas velocity and Mach number just shows you there. Quite a useful tool is this result graph here. If you click on that, it comes up with this here. And basically you can, again, select what line you're looking at, but in this case we only have one line, and you can look at how things change along the pipe. So we start at 0 and we go up to about 25 meters. So you can select, for example, if we want to look at fluid pressure versus temperature, so you have blue line would be fluid pressure and say red to be fluid temperature. So you can see, okay, as the first compressor, then you lose some pressure through your piping, and then the pressure increases again at your second compressor. You can see your fluid temperature over that, so temperature increases, cools down, and then heats up again. You can also look at gas velocity, and everything that you can see here, actually more than you can see on the color scale, you can see here, and it gives you exact values for it. So if you want to look at, for example, your maximum there, it tells you, take that, it tells you your maximum pressure and maximum fluid temperature, and it tells you the point there. The second one you can do, if you want to select a specific point along your pipeline, you can have this drag point, and you can move this along here. So say we want to know a point at the along this piping here, so for example at 15 meters, it'll tell us where we are and our values there. You can also minimum, choose your average, and so on. It tells you here, if you look at this, it tells you your pipe. So you can see the pipe, this is in the heat exchanger, the pipe diameter has changed again, and then at the start it's larger, and you can see how the pipe diameter changes. Also notice that through the heat exchanger here, because we have a water box around this, it changes. It has a highlighted region there where we can see where it takes effect. And it tells us our various temperatures, so we can also graph wall temperature 1, 2, 3, 4. This is defined there, but basically you have different temperatures along and throughout your wall, so inside, outside, or if you have cladding, it'll tell you your temperatures throughout that, and so on. Cool, thank you.